All right, so we're going to start with the review, and we'll start in order. So that would put us at number 19. 19 would be the first one. Let's do number 19. All right, and I think Hunter, that was you. So tell me what the problem is.
The limit as x approaches 4 of the square root of x minus 3 minus 1 over x minus 4.
Okay, so direct substitution fails. So after that, because we have something in the numerator like this that has a radical, the trick we've used in the past is rationalizing the numerator. So we're going to multiply by the conjugate of this. So x minus 3 plus 1. Top and bottom. So that equals the limit as x approaches 4 of, now when we FOIL this out, we're going to get that the radicals cancel out. So we're left with x minus 3. And then because we're multiplying by the conjugate of it, we don't have to do the OI part of FOIL because they'll just factor out. Okay? So we're going to skip that. And then we're also going to do the negative 1 times positive 1, and that will give us minus 1. Divided by, for here, I'm not going to distribute. I'm just going to write the factors x minus 4 times x minus 3 plus 1. Reason being is because when we simplify the numerator, we'll have a factor that can cancel. Okay, so we get that this is equal to the limit as x approaches 4 of x minus 4 over x minus 4, x minus 3 plus 1. So, because these factors are the same, they will divide out, leaving us with 1, limit as x approaches 4 of 1 over the square root of x minus 3 plus 1. At this point in the game, let's try direct substitution. Hopefully it works. If it doesn't, then we'll cry. Yeah. We'll cry. But it does. 4 minus 3 is 1. Square root of 1 is 1. Plus 1 is 2. So this equals 1/2. Okay. Cody, this is a no-hate zone. I'm trying to promote a positive learning environment, and you just ruined it. He was an elephant, wasn't he?
Big ear dog.
Yeah. He always scared me as a kid.
They could fly with his ears.
Right.
They started flopping.
Now I remember. Yeah, bringing back bad memories. My goodness.
Ben,
Yeah.
can we throw 21 in there? Oh, you did that one yesterday?
Yeah. Watch the video.
Gotcha.
Yep. 41. 41. And Hunter, I think that was you too. So tell me what it is.
The limit as x approaches 4 from the left of the square root of x and minus 2 outside that over x minus 4.
Okay. So you could. I saw someone do this on the quiz yesterday, or not yesterday, but the one with the second quiz. You could divide by x in the denominator, and thus it would be x squared under the radical in the numerator. Do you want to see that, or do you want to see? Here's what I would do. I would evaluate it at numbers approaching 4 from the left. So I'd pick numbers like 2, 3, 3.5, and just see what happens. So as I plug this in, I would get the square root of, in fact, I might even do 0 just to make it nice. 0, 1, because the square root of those numbers are nice. So the square root of 0 minus 2 divided by 0 minus 4. And then that would give me negative 2 over negative 4, which would be positive 1/2. And then I try it at 1, and I say, well, the square root of 1, that's the square root of 1 minus 2, divided by 1 minus 4. And this is negative 1 divided by negative 3. So that would be a positive 1/3. And then I try doing 3.5, and here's where we'd have to get the calculator. So the square root of 3.5 minus 2 divided by 3.5 minus 4 is negative 0.5. And it looks like it's approaching 0, but let's just see what this one does. So square root of 3.5 minus 2 divided by negative 0.5. And, although that's not right. Oh yeah, because I need to do order of operations. So let's get rid of that. Let's get the numerator in there first, and then divide that by negative 0.5. And I get 0.25. 0.258. So 0.258. So maybe it's not. Maybe it's approaching 1/4, right? So you could try more numbers like that, but
The only way to figure it out.
no, I'm about to do it another way. Okay, so if that doesn't scream at you saying here's what it is, then let's go back and do the crazy algebra. So we're going to divide by x in the denominator, and in the numerator we're going to divide by the square root of x squared.
I thought you only did that with infinities.
You might be right. Let's see what happens. I think you are right. But let's see what happens. 2 over square root of x squared. So this would be 1 over... Okay. So then, I'm just going to do some crazy algebra real quick. This would be 1 over x minus 2 over square root of x over just 2 over x, and then divided by 1 minus 4 over x. Yeah. So then we're getting, yeah, we only did that with infinity. So let's try doing one more number then. Let's try doing maybe 3.9. Ah, yeah, that's even better. Did you do that? Okay, cool. So conjugate would be the way to go. Multiplying. So we already did that in like number 19 by conjugate. But sometimes you don't see that right away. So you got to try what works, try what comes to mind, which is also another good way if you're taking a test and you're staring at it, don't stare at it too long. Circle it, skip it, come back, right? So yeah, multiply by the conjugate for that one. So square root of x plus 2. Would you like me to do that, or should we?
Yes.
Yep. Okay. So let's take this. We're going to multiply by square root of x plus 2 over square root of x plus 2, yielding then x minus 4 in the numerator, and then in the denominator it would be x minus 4 times square root of x plus 2. And that's, I'm not going to write the limit notation, but you would need it. And then cancel those out, and then you have 1 over the square root of x plus 2. And now we can evaluate it. So let's put 4 in, and we get 1 over the square root of 4 plus 2. Square root of 4 is 2, and indeed that is 1/4. Okay, So we were right with our estimation. If we had done 3.99, we would have seen that it was getting closer to 0.2500. Okay? So the limit is 1/4. All right. Let's do number 43. Was not on our homework? Yeah, Ashley?
How do you know, so when it's four approaches from the left side, where it's real or is it?
It might. Yeah, because like on our quiz, remember how we had a discontinuous function? So if it's discontinuous at 4 and it's like a piecewise, it might approach something else up here. And then down here would approach something else. So yeah. Right, like it would tell you the different parts of it or whatnot. So, but yeah, if you're doing the guess and check method, if it's 4 from the left, you need to pick numbers that are smaller than 4. If it's 4 from the right, pick numbers that are bigger than 4. Good. So 43, was that not part of the assignment? Is 43 part of it? All right, let's skip it for now. Let's go to 61, particularly 61A. Anna, read that for us.
It says let f of x equal consensus x squared minus 4 divided by the absolute value of x minus 2. Find each limit if it exists.
Okay.
And A is the limit of f of x as x approaches 2 from the
2 from
left.
the left. Okay. So, because of the absolute value, I get scared about just trying to factor and divide out, right? So this one, my first gut feeling would be to do just a quick table of values. So approaching 2 from the left, let's try 0, 1, and let's try 1.5 and 1.9. If we plug 0 in, we get -4 over the absolute value of -2. So it's, right, yeah, so it's -4 over 2, which is equal to -2. If we plug 1 in, we get 1 minus 4 is -3, divided by 1 minus 2, which is -1. The absolute value of that is 1. So that's -3. If we plug 1.5 in, we get 1.5 squared minus 4 is -1.75, divided by, well, 1.5 minus 2 is -0.5, but the absolute value of it is +0.5. So we're going to take that -1.75 divided by 0.5, and we get -3.5. Okay. And let's try 1.9. So 1.9 squared minus 4 is -0.39, and we're going to divide by 1.9 minus 2 is 0.1. -0.1, absolute value of it is +0.1. So divided by 0.1 is equal to -3.9. So what's it approaching? Yeah, -4. So that's -4.
And then there's like a little like jump in the graph that goes from -4 because then like the next one is like as it approaches 2 from the right.
Okay.
And that one's like +4.
Right.
The answer.
Reason for that.
Jump.
Yeah, reason for that is because of the absolute value sign.
Mhm.
Okay, so all of these values, once you get past 2, so let's try 2.1. All of the numbers are going to be the same, but they're going to be positive. So there's going to be a jump in the graph, and that's because of the absolute value signs.
Okay. And then there's just a hole.
Right. Yeah. There's a hole for both of them. So trying to figure out what this would look like. 0, -2 is right here. At 1, it's -3. At 1.5, it's -3. 3.5. Yeah, so it's like a negative 3, 1.5 negative. 1, 2, 3, negative 3.5, and then like 1.9 is negative 3.9. Yep. Like down here. So then there's a hole, and then it goes up here, right? For the other ones. Yeah. It jumps up here and does the same thing, but it would go probably, I don't know, I'd have to graph it, but something like that. Yeah, but there'd be a jump and there'd both be holes, because if you have 2, x equals 2, it does not exist. Okay? 61A. Good. Other ones. Let's see here. 87's next. 87. And I forget who's. So Mason, go ahead and read that for us. I know it wasn't you who picked it, but.
Limit as x approaches negative infinity, and then 6x over x plus
Okay. Limit as x approaches negative infinity of 6x over x plus cosine x. Any ideas before we start? Yeah. Okay. So if you substitute negative infinity in right away, I think you get cosine of negative infinity does not if you at negative infinity, there's no limit. It does not exist because cosine oscillates back and forth, right? So at negative infinity, it's going to be oscillating. So I don't think we can do direct substitution right away. Here's what we could try. We could try dividing by x. So let's try that. So 6x over x, but and then x over x plus cosine x over x. We do not, because that only, you know what, okay, I'm not sure on that. Every other time where we made one of them negative, it was when it was a square root. So we might. So let's see what happens, and then we'll see what the back of the book says for the answer. And then we'll compare that. So then this is 1, and then this is just going to be cosine x over x. It'd be nice if it were sine. And then this is going to be 6 over that. So 6 over 1 plus cosine x over x. Okay. So then if we do direct substitution, cosine of infinity, that doesn't exist. So then it looks like it would just be something over infinity. It looks like this might just cancel out and be 0. What's the back of the book say for the answer? 6. So then, okay. So then this would be, what's that? Yeah. So then this portion we could say is 0. And then it would be 1 plus 0 is 0, so the answer would be 6. Yeah, so I think when you're going to make it negative whenever you're dividing by the square root of something, because whenever you take the square, you have a positive value or a negative value. So that's where that comes in. Yeah. When it's technically both. When it's positive infinity, you're taking the positive square root, but we just normally do that without even thinking. So, but when it's negative infinity, you're going to take the negative square root. Okay. 93. Madison, would you read that for us, please?
F of x equals 5
Okay. So, so we're just looking for horizontal asymptotes for this one? Okay. E to the negative x is going to give us a, if it were e to the x, that would just be, I believe that's 1 over e to the x. Well, let's use the graphing utility, because that's what they say to do. So, I think I'm going to practice
You're gonna
mine.
need to know how to show the algebra.
If it says use the graphing utility, then you can just graph it, and that's fine.
But then like this, we would need to know how to graph that.
Right. Yep. So let's do a graph. Never safe to assume anything. You know what they say about whoa.
Keep on messing with the goals sooner than you know.
X is equal to 5 over over 3 plus 2 e to the negative x. Oh, it's gonna be negative x. Okay. So it looks like we have two asymptotes. One is 0, and the other one appears to be 2, but it's really hard to tell because is it 1? What's that? 2/3? 5/3?
How are you supposed
Or
to?
is it
Mhm.
really hard to tell? Like,
Right.
and then you can algebra.
It has to be.
Well, it looks like if it's 5/3, it looks like it's just 5 over 3. But I would assume that's a hard fast rule. But yeah, so that's what I go with 5/3. Because why would that be? Why would that be? Is
I
because
do more than the one horizontal asymptote.
we talked about that if there's ever like a square root, there's other functions that have this, and we've seen them. In fact, there was one on your quiz, I believe. Maybe not, but it's when you have things in the denominator like this. So if you plug in, basically what this means is you'll never get a negative answer because the only x here is in the exponent. So negative exponents don't mean negative values. That's just going to mean really small fractions. So no matter what x value we throw in here, we're never going to get a negative. So that means one of our horizontal asymptotes is going to be the x-axis. The other one, no matter what goes in here, if we no matter what the denominator is, it's going to be 5 divided by whatever that is. Okay, so because 5 divided by 3 plus whatever that is, so if it were infinity, if this were infinity, that might be a good way to look at it. If this were infinity right here, then, or in fact, if it were infinity, if x were infinity, it would be 5 over 3 plus 2 times e to the negative infinity of power. Well, e to the negative infinity of power is 1 over infinity. 3 plus 2 times 1 over e to the infinity. And e to the infinity is infinity. So this right here, as x approaches, so the algebraic way to do it is by evaluating the limit. So here's how to do it. Had the epiphany. Here we go. Evaluate the limit as x approaches infinity. So we plugged infinity in, direct substitution. E to the infinity is just infinity, so this becomes 5 over 3 plus 2 times 1 over, a really big number is 0. So then that just becomes 5/3. So that would be a horizontal asymptote,
Okay, so 5/3 would be a horizontal asymptote.
which is the limit as x approaches infinity.
Okay. and
Okay.
How do you know that how do you know that x is, how do you know that 0 is?
Okay, so let's do as x approaches positive infinity now. 5/3 plus 2 times e to the negative infinity. So negative infinity is what we're looking at. That makes it positive infinity, right? So that would be 5/3 plus 2 times e to the power of infinity. Well, e to the power of infinity, that's a really big number. Times 2, it's still a really big number. Add 3 to it, it's still just a really big number. So this is 5 over a really big number, which is what? 0. So these are the two asymptotes without graphing it. Cool. That's all you guys said earlier. Other ones? Other ones? Yeah.
For 75,
Mhm.
the answer is like 4/5. Do you get that just by canceling out like the x's to the
What's the problem?
limit of sine 4x over 5x
Sine
as
of 4x
x approaches 0 from the right.
Okay, so in order to do this, we're going to multiply by 4/4. Because I want this right here to be the same in the denominator. So this equals the limit as x approaches 0 of the sine of 4x, but over out front I need the 4. Divided by, I'm going to shove this 5 over and replace the, put the 4 that I multiplied by right there, because multiplication I can reorder that just fine. So then this portion is equal to 1. So this is equal to 4/5 times 1, and that equals 4/5. Cool. Others? Others? Have a good day. I'm going to stop recording now so you guys don't get angry at me.